Building quickly. Essential machine learning routines for practitioners to master today. Machine learning (ML) is a rapidly evolving field, and staying up to date with the latest practices can significantly boost productivity. This essay outlines essential ML routines that practitioners should master today to accelerate their workflow. 1. Data preprocessing. Cleaning and preprocessing data efficiently is crucial for any machine learning project. Utilizing libraries like Pandas for data manipulation and scikit-learn for data preprocessing can save valuable time. The pandas.dataframe.dropNA function allows you to remove missing values in a data frame, ensuring your model doesn't learn from corrupted data. Cleaning and preprocessing data effectively sets the stage for accurate modeling and faster results. 2. Feature engineering. Creating meaningful features from raw data can significantly improve model performance. Techniques like one-hot encoding, polynomial features, and feature scaling are fundamental to any ML project. Using sklearn.preprocessing.one-hot encoder for categorical variables can help the model capture more information. Feature engineering allows you to create new features that better represent the underlying data, resulting in improved model performance and quicker insights. 3. Model selection. Choosing the right model for a given dataset is essential for optimal results. Libraries like scikit-learn and TensorFlow offer various models, each with its strengths and weaknesses. For regression problems, sklearn.linearmodel.ridgecv provides regularized linear regression that can handle high-dimensional data. Selecting the appropriate model ensures efficient learning from your data, saving time on unnecessary experimentation. 4. Hyperparameter tuning. Optimizing hyperparameters is a critical step in ML model development. Grid search and random search are common techniques for finding the best combination of hyperparameters. Using sklearn.gridsearch.gridsearchcv can help you find the optimal regularization strength C for an SVM classifier. Properly tuned models learn more effectively, reducing the need for multiple iterations and improving overall performance. 5. Model evaluation. Assessing model performance accurately is vital to determining its usefulness. Metrics like accuracy, precision, recall, F1 score, and AUCROC should be used depending on the problem type. For imbalanced datasets, precision, recall, and F1 score are more informative than accuracy. Understanding when to use each evaluation metric ensures that you make informed decisions about your model's performance. 6. Model deployment. Once a model is trained and evaluated, it needs to be deployed for real-world usage. Tools like Flask and FastAPI can help create efficient web APIs, while libraries like TensorFlow Serving can handle more complex models. Using FastAPI allows you to build a scalable and easy-to-maintain API for your model with minimal code. Deploying models quickly enables their integration into various applications, increasing their utility and value. 7. Continuous learning. The ML landscape is continually evolving, so it's essential to stay updated on the latest research and techniques. Following influential researchers, attending workshops, and participating in online forums can help keep you informed. Attending the annual NeurIPS conference allows you to learn about the latest advancements in machine learning from leading experts in the field. Staying up to date with the latest ML techniques ensures that you are using the most efficient practices, saving time and improving results. By mastering these essential ML routines, practitioners can significantly speed up their workflow, increase productivity, and stay competitive in today's rapidly evolving machine learning landscape.